Distinguished organizing committee and teachers, our work is DBS, blockchain-based privacy-preserving RBAC in IoT. I have the honor to introduce our work as follows. The emerging technology of blockchain may provide viable schemes for IoT access control, and some architectures for IoT access control have been proposed, but the current schemes of IoT access control still face the following challenges: management, security and privacy, cost. To address the above issues, we propose DBS, which is a privacy-preserving RBAC architecture based on blockchain in IoT. Comparing with previous work where an access policy indicates a manager's access authorization to a single device, we extend the traditional RBAC with a new domain to make DBS fit the access control of IoT. Through this method, we can manage the access policy in a bunch manner, and it can deal with the scenarios by calling about two functions when many access policies should be changed. DBS leverages zero-knowledge proof to protect the privacy of transactions and combines with the TEE to ensure the confidentiality and the integrity of the smart contract. Finally, we implemented and evaluated our scheme, and the results show that by introducing the RBAC model, it can simplify management, preserve the privacy of access policies, and achieve convenience and flexibility to access and manage the IoT devices. Resource. This is our system architecture. In the figure, the resource owner (RO) is the owner of the IoT devices, responsible for managing the access control permission of a set of IoT devices and has the highest management rights. Any entity can become a resource owner by registering its own IoT device on the deployed smart contract. Access Requester (AR). AR refers to the people who want to access the IoT devices to obtain relevant data, operate and manage IoT devices. There are two types of access requesters: the access requesters in the domain and the cross-domain access requester, such as family member and non-family members. Consensus node (CN). CN is a blockchain node in our architecture. It's not only responsible for verifying and processing transactions, but also for deploying and executing smart contracts. Smart contracts (SC). We use management operations in smart contracts to manage the access control. All the operations allowed in the access management system are triggered by blockchain transactions. We utilize two smart contracts, an authorization contract and an authentication contract, to assign roles and check access rights respectively. And we use gateway to connect the blockchain network, and IoT devices. IoT devices can be smart home devices, mobile devices, wearable medical devices. The key system of DBS is shown in the figure, where A represents a sender, which can be the resource owner and or access requester in the system. B stands for a receiver, which can be a smart contract in the system. To protect the privacy of smart contract and access control process, we use trusted execution environment technology in DBS. In detail, firstly, the RO will request the TE from the CN through a secure channel. The CN initializes an enclave in the local TE. The enclave will generate an key pair, of which the private key is only kept by the enclave, so that the subsequent invocation can be protected by public key. After receiving the access request, the CN will send the enclave where the invoked contract is located, and then load the encrypted access request into the target enclave. The enclave will decrypt the access request with a private key, and then take the data in the access request as the input to execute the contract. The execution result is encrypted with the public key of the AR and returned. At last, after access request contraction is acknowledged, the encrypted access results will be broadcast to all nodes for the blockchain. For requesters in the domain access, the RO generates invoke transaction is encrypted with the public key of authorization contract, then sends it to the blockchain. After invocation transaction is acknowledged, the add row operation will add the information to the access control list of the authorization contract. The access requester sends the encrypted access request to the authentication contract, which will identify the access requester. For the cross-domain access requester sends an encrypted row request to the authorization contract, including signature and user ID. Then the cross-domain access requester sends an encrypted access request to the authentication contract, which will identify the cross-domain access requester. Because of the mass of IoT devices, the local gateway needs high-performance features to serve as many requests from IoT devices. We tested the throughput and the bandwidth with the local gateway, and the requests and the results are shown in the figure. We also tested the response time required for the access request from the local gateway to the IoT device. As the number of access requests increased, the response time also increases. In this paper, we investigated a privacy issue to access control schemes based on blockchain in the IoT, and we proposed an architecture with privacy preserving based on blockchain to achieve distributed, trustworthy, secure, and convenient access control. The architecture consists two parts. an access control part, and a privacy protection part. The results demonstrated that the feasibility and confidentiality of the proposed architecture in achieving distributed and trustworthy access control for the IoT. Thank you for listening.